The new episode, and today in this lesson we will learn how to detect a cycle in our linked list. In our last lesson we learned how to reverse linked list, and also we printed that. Then we could check all the result of all other methods also. So today let's learn how to check if there is a cycle, because if we do not check this, sometimes when we are traversing the list, it is possible that there is a cycle and we will fall into an endless loop. So to avoid that, we have to be able, we should be able to check if there is a cycle or not. So there are many algorithms to detect if there is a cycle or not. But one of the famous one is from the Robert Floyd, which he is using the analogy of tortoise and hare. This tortoise and hare or rabbit, it's a very famous story that you may have read that during your childhood. It is very famous. You can Google this and read about that. That's a very interesting story. The story is that the tortoise and rabbit or hare had a competition, and uh, the obvious expectation was that the rabbit should be the winner because the rabbit is much faster than the tortoise. But the winner of that competition is the tortoise. So Robert Floyd is using this analogy to detect if there is a cycle in a linked list or not. So how it works? Like, it is very obvious that the hare is much faster, and if there is not a cycle, so this faster pointer come to an end of the list, and as soon as it comes to the end list, we see that we can make that conclusion that, well, there was no cycle because we have an ending node. We have a node that points to null, and when we have a node that points to null, that means there is no cycle. But if they meet one another some point in this process, that means there should be a cycle. Otherwise, they would not have met one another. So what does that mean? That means that we need to have two pointers, that one of them should be traversing the list faster and one of them should be traversing the list slowly. So that way, if there was cycle, they will come to one node at some point. Let's see how that works. So I have two pointer. One of them is the tortoise, which is the slow pointer, and the other one is the hare, which is the fast pointer. So I name it slow and fast. I think that way it is easier to understand the meaning of that analogy. So this slow represent that tortoise and the fast represent that hare or rabbit. So when you start traversing this list and you have two pointers, so the slow, you expect for the slow pointer that it has to go to one node at a time. For example, it comes here, but the fast pointer, it moves two nodes every time, move two nodes forward. Like when they start from the head, if the slow points to the second one, the fast points to the third one. So again, when they start moving forward, so the next time the slow comes here and the fast, so it goes ahead two nodes, it comes here and here. So the next time when the slow comes here, so the fast jumps two nodes, come here and come here. So you see that at this point they are pointing to the same node. That means there is a cycle. If it was not a cycle, this fast pointer would be reaching the end of the list faster, and there would not be a meeting, a collision like between these two pointers. So using this analogy, let's write our method, how they work. Okay, so now let me write the method here. Public void has cycle. So actually, instead of void, let me write it boolean, because if there was a cycle, it has to return true, that yes, there is a cycle. If there was no cycle, it has to return false. So we need to have two pointers, node slow, and at the first time both of them has to point to the head, because we are starting traversing the list from the head. So it points to head, and also node fast equals to head. Then we start traversing the list, while we say while as far as the fast pointer is not null, or it is not pointing to null, we have to move forward. So we say as far as the fast is not null and fast.next is not null, if one of them is null, either the fast or fast.next, that means there is an ending node and there is no cycle. So we say that as far as this condition meets, we have to continue our checking, our process, our analysis. So at each time, the slow only moves one node ahead. For example, at first the slow comes here, we say slow equals, it was here, now it points to the slow.next. So we had the slow pointing to head, now it says slow equals to slow.next. So now the slow is here, and fast, it has to jump 2 nodes forward, it has to come here. So we say that fast equals to fast.next. See, if you say fast.next, it also points to this, but if you say .next 2 times, that means it points to this one. So, and every time that we move these pointers forward, we have to check that if they are pointing to the same node or not. So we say if slow is equal to fast, that means there is the cycle. Otherwise, there would not be a meeting between those two pointers, because one of them moves faster and one of them moves slowly. So, but if they point to one node, that means there is a cycle. So we say return true. But right now we see they are not pointing to one node, so this if condition is not executing. So the loop continues. Again, it checks, is fast equals to null? You see fast is not null. How about fast.next? Again, it is not null. So if it is not null, so they have to move forward. So slow comes to slow.next, slow comes here, and fast comes to fast.next. Fast.next here, .next here. So at this time when we check, again they are not pointing to the same node. So we continue checking. So this time slow comes to the slow.next, come here, and fast comes to .next. Fast.next is here, .next is here. See, at this point both of them are pointing to the same node. If this time we say is slow equals to fast, it says yes, returns true. That means there was a cycle. But if you come to a point that fast is null or fast.next is null, then that means there was no cycle, and we say return false. That was it. So I hope it was clear enough for you to understand the concept. And for your information, in order to learn it faster and easier, I think once you need to read that the story of tortoise and hare. It is a very famous and interesting story actually. And using that analogy, you will remember this algorithm. You will not forget that easily. So it is the easiest algorithm that I think, but you may find other algorithms easier for yourself. That's fine also. There are many algorithms to do the same thing, but it's quite easy and you will learn that faster. And always first try to visually solve them, then you will come to a solution. So until the next lesson, have a nice time everyone.